and 17 Pacific Atlantic water flow. Let's first try to understand the problem. Yeah, so according to the drawing, so at the top and the left side, so that is the Pacific Ocean, and at the right and bottom side, that is Atlantic Ocean. So there's a condition for the water flow. So for example, if this value is 4 is more than this value 3, more than and equal to this value 3. It means the water can flow from 4 to 3. Yeah. Similarly, 3 to 2, and this 2 to 2. So if this value is more than or equal to this value, it can flow to 2. So 2 is more than 1, it can flow here. And this one is connected to the Pacific Ocean. This means this point can flow to the Pacific Ocean. And similarly, this point can flow to 4, maybe 4 to 1, and 1 to the Atlantic Ocean. So if these points can flow both Pacific Ocean and Atlantic Ocean, now we're going to put this point inside of our final result. So it's going to be an array. Yeah, let me use another color. So it's going to be inside, it's going to be an array, and it's going to be the row and column. So it's going to be the first row 1 and column 3. So we're going to put 1, 3 inside the final result. Yeah, and similarly for others, as you can see, the yellow color will be put inside an array, and that is going to be the final result. And let's just check the final result. As you can see, it is a 0, 4. It means this one, and this one is 1, 3. Yeah, this is our example 1, 3, and also for others. We just need to return this kind of structure. So the very straightforward way is we're going to check by using the brute force. We're going to check one by one. So for example, we're going to check the first one, this one. We're going to use the DFS to check if it can go to the Pacific Ocean, or we're going to check this one if it can go to the Atlantic Ocean. But this is going to be m times n square time, and m or n is 200. Yeah. So this means it's going to be a really big value, and we cannot pass for all testing cases. Yeah. So if it is like that, basically, the brute force is that we're going to check each of the points, and we're going to check if it can go to the Pacific Ocean or if it can go to the Atlantic Ocean, and this consumes the time. So instead of doing this, we should do it reversely, because this can really save time. So by reversely, my meaning is we're going to prepare two sets. So the one set, we're going to call it, so at the top left corner, we're going to call it the Pacific set. So the Pacific set will collect all the dots which can flow to the Pacific Ocean. And at the bottom right side, we're going to prepare another set. We're going to prepare a set. So it's going to be the Atlantic set. So for example, let me just use white color. Let me choose the white color. So for example, this is the Pacific Ocean. We're going to prepare a Pacific set. And another one is the Atlantic set. We're going to prepare an Atlantic set. And by using DFS, definitely we can put all the points inside the Pacific set or into the Atlantic set. So for example, we're going to start in maybe here, maybe this point. Maybe this point 3. Yeah, we're just starting from this point, because we're going to check all the borders. So for example, for the first row, it will go into the Pacific Ocean, and the first column, it will go into the Pacific Ocean. So we're going to start in from the first row and first column for the Pacific Ocean, and we're going to start the DFS. So for example, we start with this 3, and we're going to start the DFS. We're going to check if it can go to the Pacific Ocean. Definitely 3 can go to the Pacific Ocean, it is 1. And then it can go to 2, because 3 is bigger than 2. Yeah, so 2 is connected to Pacific Ocean. Yeah, and we might go inside. Yeah, but 3 is less than 4, so it means it cannot go inside. But let's just try another one. But let's just use this 3, because 3 is less than 4. 3 can go into the Pacific Ocean, so this means 4 can go into Pacific Ocean. Yeah, because 4 is bigger than 3. So we're gonna just reverse the arrow. So it's gonna be 4 pointed to 3. And also for this 5, for example, 5 can flow to 3, and 3 can flow to 2, 2 can flow to the Pacific Ocean, Yeah, so this means 5 can also go to the Pacific Ocean. But we will not doing it like this. We're gonna do it reversely. We're gonna just starting from this 2 and go reversely to 3 and to 5. So this means this 5 can also go to the Pacific Ocean. And luckily for us, for example, this one, 3 can go to 1 and 5 can go to 3, but we will do it reversely. So 1 can go to 3 because 1 is smaller than 3, 3 can go to 5, so this means this 5 can also go to the Atlantic Ocean. So in this way, we're gonna put this 5 both inside the Pacific Ocean and the Atlantic Ocean. And finally, we just need to check all the points. If it is inside the Pacific set, and also it is inside the Atlantic set, and then we're gonna collect it in our final result. So this is gonna be the final answer. Yeah. So the idea is that we're gonna just do it reversely. So this is the Atlantic set. We're gonna connect all the Atlantic set with the borders at the bottom right side. Yeah. And for the Pacific Ocean, Pacific set, we're gonna collect all the borders from the top and the left, and then we're gonna start the DFS to check, and we're gonna put all the possible, yeah. So for example, we're gonna put all the possible dots inside the Pacific set. So it means basically at these areas, we're gonna put it inside the Pacific Ocean, and at these areas from here and here, at these areas, definitely we're gonna put it inside the Atlantic set, and then we're gonna just union the two sets. We're gonna check the final, the union result of the two sets, and it's gonna be the final answer. So now let's just try to solve the problem. So let me just copy the directions, because definitely we need directions. Let me just copy a random direction variable, because definitely I need some variable called directions. Let me just copy some code from here. And I need to have this directions. It means just with 4 directions, and I will change it R and C to the length of the hits and the length of the hits 0. Yeah. Now let me just prepare a Pacific set and Atlantic set. It's going to be an empty set. Yeah. And then I'm going to prepare the DFS function. But before that, let me first finish the main function first. Yeah. So I will give a pause at the moment. So my final return gonna be all the dots with the R and C coordinates. So for R in range, capital R, for C in range with capital C. So if this tuple RC is inside the Pacific set, and it is also inside the Atlantic set. Yeah. So this is gonna be the final return. Yeah. But before that, let's just try to finish the main function first before the DFS. Yeah. Actually, the DFS is gonna be a position of R and C, and I will prepare a set, because definitely we want to put all the dots inside a set. So I'm gonna prepare a set. This S is gonna be a set, and then I'm gonna prepare a previous hit. Yeah, because definitely we need to compare the hit. This is 3 with this 5. Yeah, so if this 3 is less than 5, it means the water can flow from 5 to 3. Yeah. Now let me just finish the main functions first. So it's gonna be the 2 for loops to check. So for C in range with capital C. So I'm gonna check the first row and the last row. So the first row will be connected to the Pacific Ocean, and the last row will be connected to the Atlantic Ocean. Yeah. Let me just check the first row. So for the Pacific Ocean, I'm gonna add the first row. So it's gonna be 0, 0C. Yeah. I'm gonna put it inside the Pacific set, and then I'm gonna run the DFS. For example, this is the first one. I'm gonna run the DFS to check it might connect it to other points. Maybe this one connected to 2, with this 2, this 4, and a lot of things will be put inside the Pacific set. If I put it inside for the next one, if it has already inside the Pacific set, I don't need to do it. That is why the time complexity becomes linear. Here the linear, I mean, it is m times n. It is not m times n times m times n. It is just m times n. Yeah. Now let's just run the DFS. So the DFS is going to be from this point, it's going to be 0C, and I'm going to prepare the Pacific set, and then I'm going to prepare the height. So the height is going to be the height 0 and C. Yeah. And similarly, I can prepare the Atlantic Ocean. So A need to append the Atlantic Ocean. So Atlantic Ocean is going to be R-1 with C, and similarly, we're going to run DFS. It's going to be with R-1. It means the last row, and with C, it means the column position, and we're going to put it inside the Atlantic set. So this is going to be the Atlantic set, and we're going to prepare the height. So the height is going to be R-1 with C. Yeah. So this is going to be the first row and the last row. And similarly, we're going to prepare the first column and the last column. Yeah. And so for R in range, and capital R, because the first column will be put inside the Pacific Ocean. So we just put it inside. So we're going to add so the first column going to be R with 0. Yeah. And we're going to run the DFS. It's going to be R with 0. And it will be inside the Pacific set. And we're going to prepare the height. It's going to be R and 0. Yeah. And then we're going to prepare the Atlantic set. So it should end the Atlantic set. So it's going to be R with C-1. It means the last column. Yeah. And then we're going to put it inside the Atlantic set, and we prepare the height. So the height is going to be the height is going to be R with capital C-1. It means it is the last column. Here I needed to, this is not okay, because this is just a tuple, and this is just for DFS. Let me just, put it inside of the DFS. And this tuple gonna be R and C-1. It should be here, yeah. So I think that is the entire code. For the main function. So the main function gonna be just a for loop to check the first row and the last row. And for the first row, we're gonna put its points inside on the Pacific set, and we're gonna run the DFS. And here, similarly, we're gonna put it inside of the Atlantic set, and we're gonna run the DFS. Yeah. And let me just check here. This is the first column, and we're gonna put it inside the we're gonna put it inside the Pacific Ocean, and we're gonna run the DFS. Yeah, and we're gonna put it this last column. We're gonna put it inside the Atlantic Ocean, and we're gonna run the DFS. Yeah. Now I think what missing is the DFS function, and this should be easier, because this is just a very easier DFS. Let's just check the 4 directions. So inside of the 4 directions, we're going to prepare the row and column. So it's going to be R plus dr and C plus dc, and we're going to have a boundary check. So if the row meets the condition and the column also meets the condition, and we're going to check the row and column tuple. Yeah, if it is not inside of the weighted set, not inside of the set S, yeah, and also we're going to compare the heights. So the previous height going to be here. So this means the previous height should be less than and equal to the new height. Yeah, for example, this one is less than and equal to 2. It means if 2 can flow to 1, can flow to the Pacific Ocean. Yeah. So it's going to be less than and equal to the current row and column. Yeah. So it's going to be with height, the new row and new column. So if it meets the condition, definitely we want to put it inside the set first. So it's going to be the row column tuple, and we're going to run the DFS. It's going to be row, column, and the set is going to be the same, and the heights will be updated to the new heights. So it's going to be height row and column. Yeah. So I think this is going to be the entire code. Although there's a lot of coding, but the idea is I mean, the idea is very straightforward, or the idea maybe very straightforward is like brute force, it didn't work. Oh, maybe you need to just reverse thinking to go back. So why not just starting from the Pacific Ocean and starting from the Atlantic Ocean and put them all inside the set. And finally, I just want to check the union of the two sets. And the final result is going to be the union of the two sets. Yeah, I'm not sure, just let me run it first to check. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works and it's pretty fast. Yeah, so this two for loops is just a union of the two sets. I'm not sure if there's other method can make the set union really fast. Or maybe we can use a union P. I'm not sure if this works. It didn't. Yeah, let me check what is inside a union P. Yeah, because definitely the set can use union. So this is not union. This is all. I think this is and. So for the union, I forget. Maybe it is. Yeah, I forget how to a dot union b. I forget about it. Yeah, maybe I need to check, but I think it can calculate directly. It's not B. It is Atlantic and Pacific Ocean. Yeah, I'm not sure. Let's just try. Let me print out. Yeah, it is not union. It is not union because union is a dot. Yeah, I forget. Maybe in Python, I think there's just a formula to calculate it directly. If it is not union, I think it is. Yeah, it is and. I forget. A at P? No. I don't know. Yeah, I forget how to check the formula, but maybe we're gonna use this one. This one is also easier. Just need to check if all the points is inside the two set. I think that's all for it. Thank you for watching. See you next time.